Today's lesson is going to cover topics that involve standard deviation. Before we begin, take a minute to read the following problem and answer the questions provided. Now would be a good time to press pause and answer these questions. Okay, let's see how you did. The problem states Alex has played baseball professionally for the past 9 seasons. Below, they give you a table of the number of home runs he scored each season. So remember, this is home runs scored. Part A asks us to calculate the mean, median, mode for Alex's home runs. If we look at all our data points, nothing repeats. Therefore, our mode is no mode. You cannot write 0 because 0 could be a mode. When nothing repeats, we write no mode. Next, we have to calculate the mean. Sorry, let me get rid of this. Our mean is calculating by adding all of our data points to find the sum of 279. There were 9 total seasons, so we divide 279 by 9 to get a mean of 31. We can't find our median until we've taken all our numbers and put them in numerical order from least to greatest. If you notice, I use different colors. If you don't have different colors, you can do as I did and change the slash direction. So I put a slash through the 7 and the 49. Then I switched my direction, the 40 and the 20. That's how I know I'm taking one from each end until I arrive at the middle point. And since there was an odd number of seasons, there is one middle number. My median is 33. Our problem then asks us which measure best represents the home runs. If you recall from our previous lesson, we would use the median because the data is skewed. We have an outlier of 7 as compared to all our other numbers. The general manager of Alex's team wants to trade Alex. Which measure of center should the general manager use to convince the team owner that they should trade Alex? My reply was the median. The median shows a larger average of home runs, meaning he is a benefit for the team they would be trading him to. Our next topic is standard deviation. Don't worry, don't freak out. You're not going to have to memorize this formula that's provided here for you. You won't necessarily have to actually calculate the standard deviation, but you'll have to use it as Algebra Nation did with our normal distribution curve. But in order to use it and work with it, it's important for us to understand how they arrive at our standard deviation. It's also critical that we know that standard deviation is sensitive to extreme values, meaning our standard deviation is typically seen when our data is evenly spread out. Also, our standard deviation is going to vary less when there are multiple samples. So if you have multiple data, your standard deviation is not going to vary as much. Well, what does standard deviation mean? Think about what the words are. Standard. What is standard? What goes for the majority? We also see it right in the word, deviation. Deviation means how much does it differ? Does it change from the mean? So let's take a moment and let's watch this video. Again, you can pause at any time and take notes where needed or review back so that you understand how it's calculated. Hold on, we have a commercial, and here we go.
How to calculate standard deviation. How many vegetables do you have in your fridge?
Turn our volume up.
We can use standard deviation to know whether someone's behavior is normal or extraordinary. Standard deviation, often calculated along with the mean of a data set, tells us how spread out the data is. It is used for data that is normally distributed and can be easily calculated using a graphing calculator or spreadsheet software, but it can also be calculated with a few math operations. We're going to use an example involving the vegetables 5 of our friends have in their fridges. They have 2, 3, 4, 7, and 9 vegetables. To calculate the standard deviation, the first step is to calculate the mean of the data set by x with a line over it, also called x bar. In this case, the mean would be 2 plus 3 plus 4 plus 7 plus 9 divided by 5, which equals...
They're using this variable so that you understand the difference between what is coming. The bar is just stating that this is your total mean of your data set.
5. Our average friend has 5 vegetables in their fridge. The second step is to subtract the mean from each data point to find the differences. It's helpful to use a table like this. 2 minus 5 equals negative 3, 3 minus 5 equals negative 2, 4 minus 5 equals negative 1, 7 minus 5 equals 2, and 9 minus 5 equals 4. The third step is to square each difference. This makes all the differences positive so they don't cancel each other out. And it also magnifies larger differences and minimizes smaller differences. Negative 3 squared equals 9, negative 2 squared equals, negative 1 squared equals 1, 2 squared equals 4, and 4 squared equals 16. The fourth step is to calculate the mean of the squared differences. 9 plus 4 plus 1 plus 4 plus 16 divided by 5 equals 6.8. The final step is to take the square root. This counteracts the squaring we did earlier and allows the standard deviation to be expressed in the original units. The square root of 6.8 is about 2.6, and that's the standard deviation. We're done. The mean number of vegetables is 5 with a standard deviation of 2.6 veggies.
What this means is that on average, the mean number of vegetables in our refrigerators of all our survey is 5. The standard deviation of 2.6 means it will range to above or 2.6 below, depending upon the individual.
Veggies. Knowing that about 2/3 of the data fall within one standard deviation of the mean, assuming the data is normally distributed, we can say that about 2/3 of our friends have between 2.4 and 7.6 vegetables in their fridges. To recap, these are the 5 steps for calculating standard deviation. Calculate the mean, subtract the mean from each data point, square each difference, calculate the mean of the squared differences, and take the square root. Using symbols, the equation for calculating standard deviation looks like this. Lowercase sigma stands for standard deviation of a population. Uppercase sigma tells us to calculate for each instance. X is each data point, X bar is the mean of the data points, and N is the number of data points.
Again, this formula, this complex formula, you do not need to memorize and you don't need to calculate it. However, it is good to watch this video on replay should you need a better understanding of where these numbers are coming from. This is taken from your Algebra Nation book. Your standard deviation is your typical distance that data varies from the mean. The larger the standard deviation, the farther the score is from the mean. Standard deviation is typically used for a normal distribution. Take a look at these 2 dot plots. Take a moment to pause now and do your best to answer the question below. The question asks, which data set has a larger standard deviation? Explain why. Okay, let's see how you did. I can look at this first store and see that most of my data, if I were to take my pencil, is evenly distributed. When I come over here, I have this outlier. This tells my brain that the standard deviation here is going to be greater than my first store because the data value is farther from the mean. We're going to touch on the empirical rule in a day or two, and that's where you will see the standard deviation come back into play in larger. What you need to understand is the standard deviation explains that 68% of values fall within one standard deviation of the mean. 95% of those are 2, and 99.7 are 3. If there are any questions regarding standard deviation, please reply to the comments below or make a comment on our discussion board on Blackboard.